Hi everyone, you're in a train room and I'm going to show you some electronics that I developed for this layout. And I had put the layout down, I put a couple reverse switches in, and I started putting in the background and rocks and all this other things. But along the way, because I've done the cardinal rule of never ever putting a switch inside of a mountain, I needed to develop a switchboard that could handle and tell me what direction the switches were going to go. So I'm going to show you the switchboard that I developed and the lighting, and then I will talk about how I created the circuits for the lighting. So as I mentioned, I had to have a switchboard for the electronics that I have. Here is the switchboard that I have. It's a small room, so I have a pull-out unit. And I also have a switch here that allows me to turn the lights on and off. I happen to really like running my trains in the dark, and these LEDs are very bright. So you can't, it's not quite as nice of an effect of seeing the headlights of the engines or the passenger cars. So in case when I turn off all the lights, I can just turn this off, and the switch machines still work through the toggle ones, but the LEDs don't. So as you can see, there are red-green LEDs for all the various switches. This is the diagram of the layouts. And what we're going to do is we're going to focus on this area and take a look at how the LEDs functions here. All right, so here's the focused version of this double reverse loop. You got to remember that half of this, as I mentioned, is inside the mountain. And it's, of course, I can't see what the switches are set to. And in order to tell which direction the train is going to come out and which are the 4 tunnels it will come out of. And what I wanted was an LED that was green for the direction it was going and red in the direction that it was not going to be going. So that if a train was supposed to go here, it'd be green, green, or in this case, green, green. And that tells me that if the train is coming here, I won't have derailment. If I flip this, I would know that I'm going to be in a derailing situation, because I can just very quickly visually tell that the switches are not set correctly. Again, if it's coming in this direction or coming in this direction, I know there would be a derailment. I'm able to flip, and this becomes green, that becomes red, and vice versa. Or if it was coming this way, it would derail until I flipped it in that green position. So I had looked for these red-green LED combination where one side would turn green and the other side would turn red simultaneously, and I couldn't find those electronics, and that's what I really wanted to develop. And this is what I'm going to be showing you in a few minutes. We're going to go look at the electronic diagram, and then I drilled the holes in the right places and put in these LEDs and these toggle switches. I also really like these little rubber thingies on top of this. It makes it a little bit more tactile, but again, these have to be momentary double pole, double throw switches, and we'll talk about that in a little bit. So it actually works quite nicely. I have not had derailments when I pay attention to this. When I don't, there's of course derailments in some way or other. All right, so let's go take a look at the wiring diagram. Okay, we're back. Here's the wiring diagram, and although it looks complicated, it really isn't. And it's not that you have to be any good at electronics, because I'm not. You just need a good friend who is. And you know, I just follow this particular diagram very closely whenever I make one of these units for the red-green LED. So it's not particularly too complicated, although it seems that way. And I'll just walk you through what each one of these. So this one here, this is a double pole, double throw toggle switch, and it's momentary. The reason that it needs to be momentary is so that it doesn't burn out your your switch machines. So here is what it looks like. Here's the momentary switch, and the way it does is that when you flip it, it comes back to the center position. On the underside, there's 2 rows of 3 pins, and one of these rows, these 3, will be used for the LEDs, and these 3 will be used for the switch machines. The reason I have to have this situation is because the LEDs take 12 volt DC, while the switch machines are 18 volts AC. And so I need a toggle switch that will control both the AC and DC currents so that they're matched, and that's why it's a double. It's doubled this way. Okay, so just very much like there's these 3 rows, we're going to go down here, and what you can see is these 3 for the LEDs. The center one is connected to the 12 volt DC, so you just need, and I'll go through the parts list pretty closely. And then you have a 100 ohm resistor. These little round thingies means that the wires, this wire and this wire, are not connected, and it connects out to these to this latching relay. And the latching relay, and I'll go through the parts list in a minute, is this particular piece of equipment. It's yellow. The underside, as you can see, has 2 rows that are parallel. Here is a 3, a space, and 2. Again, 3, space, and 2. And all I do, I have no idea how anything works inside that little box, but what I do know is if I connect it this way, things will work. So I connect one pole of the double throw toggle switch to here, the other one to the second one, and then this middle one through the resistor to this last one. And then I connect the opposing 2 to the other part of the 12 volt DC power supply. These 2 then go through a 100 ohm resistor to the red-green LEDs. And the red-green LED looks like this. And what you can see, there's many different kinds of red-green LEDs in size. So this is a 5mm one. There are 3mm ones, but I like these 5 because they put out enough light that someone with my eyesight can see. And what you can see if you look closely is that there is one side that's kind of squarish that comes off, and one side that is just an angle. The center one is the one that goes through to the power supply directly. If the current goes through here, it's red. If the current goes through here, it's green. And that's it. It's not all that complicated. And what I do is I take 2 of these red-green LEDs. Here's the second one. And you can see the square part coming off here and the square part coming off here. And I connect them in opposite directions, right? So now the square one of the top one goes with the angled one of the bottom one. Effectively, these 2 are going to be connected. And that way, if the current goes through here, and then this will be green and this will be red. And then I connect the 2 center ones together and the other opposite 2 together. And that's what this whole diagram that you're seeing over here is about, is connecting these red-green LEDs in opposite directions, but they've got to go through this 100 ohm resistor. Now, I do put more resistors than are necessary because I really don't want to burn these things out, because if I burn these things out, I will have to unsolder the whole thing. In terms of resistors, I really recommend, here are what, when you buy them, here's what they look like. Here's 3 resistors. These are not 100 ohm, but in case, I really recommend getting one of these tables. You can get them off the internet, and it tells you, each band is telling you something about the kind of resistor that you have. So if you have this table, you can work it out, but if you just buy 100 ohm, you'll be just fine, right? And I just use this chart to really help me out, and something that I keep around for quite a long time. So this is what the diagram is. I am not good at soldering. I'm very messy. And I do put it all together, and then I put it under that my switch table, and it looks good enough. Now, as far as the parts list is concerned, you're going to need, as I mentioned, the double pole, double throw toggle switch. It has to be momentary, otherwise you're going to burn out your switch machine. Then you need 2 red-green LED 3 poles, as you saw the center pole, and then depending on which direction the current goes, you get one versus the other. Again, as I mentioned, I like the 5mm one. I buy the latching relay. It's an Aeromat DF2E-L2-DC 3 volts. There are others. There's 24 volts, there's 12 volts. It's just, I use this one and it works, and I don't want to mess with something that works. Then you need a 12 volt DC power supply. You know, I happen to use something like this. Of course, you know, there's all sorts of really cheap ones, and it has to be variable because I don't want to burn it out with the 12 volts because it's supposed to handle only 3. So by variable, I can just crank it up until the lights in the LEDs are high enough and go from there. And then, as I mentioned, the resistors, and then of course you need wire. The other thing that is very helpful is very thin solder, because these pins on all of these electronics are pretty small. Very good soldering iron, good quality flux, wire clippers, and magnifying glass. Here is what I use, this kind of magnifying glass that just sticks over my head. Really helps with these very thin solder joints. In the end, the whole thing, as I mentioned, I'm a pretty messy kind of soldering person, but it kind of ends up looking like a little bit of this mess, right? Whereas here is the double pole, double throw toggle switch. Here's the latching relay. Here's the resistors and the various connections. This side over here with the blue and white wires are for the LED. This side is for the latching, is for the switch machines. And then this, on this side, gets connected to that set of 2 LEDs. As you see, the center ones here are connected together, and they go to the DC volt. These 2 go through the latching relay. This was an early attempt that I did, where I put the resistors here. I could have just as well put one single resistor before they connected. But you know, as you can see, this is kind of messy. It's not clean, and some folks are much better electronics than I do. I do like having it like this, because then I can just drill the holes and stick these through the table, and you can see them. As long as you don't squish them, because if you squish them, then you're going to get all sorts of shorts. So you just need to make sure that it's, you know, well separated under the table. And then I put a spot of glue on here and just glue it to the top of or the bottom of the table, and then drill a hole for this part, and then just put a screw up here to tighten it against the table. And then I like these little rubber thingies. They really help, but you know, just these are momentary and they flip back to the center. Turns out it's pretty nice. It's a little bit messy under the table, but that's okay. All right, so let's talk about how the the switch machine gets connected. So in here, the center one again goes to the power, and then the other 2 go to the switch machine. So here's a switch machine that I often use. You know, they goes back and forth. There's the 2 actuators are here. This side, both are connected. They go to the AC, one of the AC inputs. and then each one of this blue and green go to the opposite side of each side of that row of 3. So although these are not blue and green, but on this side would be blue, and then this would be the other side. And so when the toggle is this way, is in one direction, then it will allow the switch machine to throw the switch in one direction. And then when this is flipped this way, it will allow the other side to go in the opposite direction. Okay, so the other thing to mention is that I don't like doing these things a whole lot. I tend to, I don't like soldering very much, but I do want to make all of this function, and I do like the way it looks, and it's very helpful as it is. So the way I do this is I do this unit together. I do like 5 to 10 of these all at once, and then I'll connect this to the latching relay for 5 or 10, and then I'll start to connect them all here, and there's a couple wires there. It's one wire that connects these 2 pins together that's missing here, but I just do it in batches. That way it goes a little bit faster, and it seems to work. The last thing to talk about maybe is the cost, right? So the really nice thing is that once you've built these things, you can always reuse them, no matter what layout you decide to change. But this is going to be a couple dollars. This is the expensive part. It's about $25. It gets cheaper if you buy more. So the best thing that I found was if you know, the whole thing is maybe 30 bucks to build one of these. And so if you build them a little bit at a time, you know, it's $30 once a month for a few months, and eventually you have enough to make a full layout. So that's about it for the parts list and how I use all of this. And you saw how it functions on my bench, on my switch table. So yeah, try it out. If there are things that are better, document it and let people know. Bye-bye.